Alright, so not everyone is great at making a net for a 3D figure, so I'm going to show you how to compute the surface area without a net. First, you determine how many faces the 3D shape has and what 2D shapes they are. So for this rectangular prism, I can see that it has, 6 rectangles, but 2 of them are going to be the same on the front and the back of it. That's this here, that's color-coded. 2 of them will be the same, those were the sides of it. That's color-coded over here in blue. And then the top and the bottom will be the same. So when you have congruency, we can use that to save some steps for the addition part when we find the total surface area. So next, we have to determine the dimensions of each shape face, which, they're the shapes we just talked about. So the front in this case is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. So the height is 6 and the width is 4. The sides are 1, 2, 3 across and 1, 2, 3, 4, 5, 6 high. Here we have it. And then the top is 1, 2, 3, 4 across and 1, 2, 3 back. The 4 by 3 right there. Once you know the dimensions, then compute the area of the faces. Now because I have congruency, I can say that I have 2 of these 6 by 4s. So 2 times 6 is 12, times 4 is 48. I have 2 of the blue sides in this case, 2 of these 6 by 3 rectangles. So 2 times 6 is 12, times 3 is 36. And then the bottom and the top, I have 2 of them, and they're 4 by 3, so 2 times 4 is 8, times 3 is 24. Finally, add all of the faces areas and label with square units. So 48 plus 36 plus 24 gets us 108 units squared as the total surface area. The amount of material would take to make a box like that, or to wrap it, and that sort of thing. It gets a little trickier when it's triangular prisms. This is a triangular prism where the triangle is scaling, which means all 3 of the rectangles that connect the 2 bases are going to be different shapes, or different sizes. They're all rectangles, but different size rectangles. So first we're determining how many faces it has and what the 2D shape says. It's 2 congruent triangles, there and there, and 3 rectangles. 1 on the bottom, 1 on this slanty side here, and then 1 on the back over here. Next, determine the dimensions of each face. So the 2 triangles each have a 1-foot base and a 2-foot height. The back side, that's back here, that is 3 by 2. So not that slanty measurement right there. That slanty measurement isn't this. We got to look over here and see, here it is right here. Let's see, and then the slanty side, that's this one right here. That's the 3 going across this way by 2.2 here. And the last rectangle that a lot of people forget about is the one on the bottom. It's 1 by 3 right down there. So you have to make sure you haven't forgotten any of the faces. Then you compute the area. So you've got 2 sets of half times 1 times 2 because of the triangle. So 2 times a half cancels, so 1 times 2 is 2. You've got the back side over here again. That's 2 by 3. So that's 3 times 2 is 6 feet squared. The slanty side is the 3 times 2.2. So that is 6.6 feet squared. And then the bottom is 1 by 3. So 3 feet squared. And finally, add all of the faces areas and label with square units, in this case, square feet in particular. So we got 2 plus 6 plus 6.6 plus 3 to get 17.6 feet squared. One more, I wanted to show you another prism. It turns out the pyramids that we'd have to deal with in this chapter aren't that tricky to draw a net if you want to draw a net. It's the prisms that I personally have challenged trying to draw the net and how things would connect so that the 2 bases would end up being opposite each other. So those are where I don't necessarily draw a net. But this one, it is a triangular prism again, but this time the triangles are isosceles. So what that means is that 2 of the rectangles will be congruent. So we're determining how many faces it has and what the 2D shapes are. So it has 5 faces, 2 congruent triangles, and then 1 over there, another one, 2, and then on the bottom, 3 rectangles. But when we look at the dimensions, we're going to find that we have those 2 triangles that each have a 6 foot by 4 foot. Remember, it has to be perpendicular to each other, 6 feet across this way, and 4 feet is going up this way. The sides, there are 2 sides that are congruent to each other, the 2 sides of this tent. So it's 7 feet this way, and then it's 5 feet if we look here. And then the other side would be the same. It would be 7 feet going that way and 5 feet here. So 7 feet by 5 feet. And then the bottom, again, don't forget the bottom. Oh, my page is just scrolled. The bottom is 6 feet by 7 feet. So that's the bottom of the tent. All right, so when we compute the area of the faces, we have 2 sets of half times 6 times 4 for those 2 triangles. And these cancel away again. So we get 6 times 4 is 24 feet squared. The 2 sides, we have 2 sets of these 7 by 5. I personally like to multiply the 2 times 5 is 10. 10 times 7, 70 feet squared. And then the bottom of it, 6 by 7. So 6 times 7, 42 feet squared, which means our last step is to add them up, making sure we didn't forget anything. So 24 plus 70 plus 42. You could line them all up and add them up if you're not comfortable with the mental math, or you can look at the ones place and say that 4 plus 2 is going to be the 6. So 2 plus 7 is 9, 10, 11, 12, 13 for the tens place. Gets you 136 feet squared. So hopefully that helps. The prisms can be tricky, so remember, take your time. Make sure you don't miss anything.